I'm going to open some tabs.
You'll never guess what happens next.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 113. Today we're talking about Python switching to match, a magnetic dyno, a flying dyno, and a spinning sequencer. Elliot, did you hear about this Google Oracle thing?
This is the case that ruled on whether an API is copyrightable?
Yeah. Do you think APIs are copyrightable?
The answer came down, no, they're not.
Yeah, the Supreme Court surprisingly sounded like they knew what they were talking about on this. I don't know why I'm surprised by that. But so the case here is going way back to Android, and it has to do with whether or not the actual API format and the calls that you use to interact with something can be copyrighted and thereby demand that you pay a royalty for any program that uses that API. I think widely the world of software engineers were looking at this and scratching their head and going, how could this house of cards that we've built continue to stand if you have to pay for the use of the APIs like this? And it sounds like the Supreme Court agreed with that stance. Something that I thought was interesting from this is they're actually, if you go and read the ruling, they're actually putting value in programmers who have learned to use the APIs and saying that if you make it so that that can't be used elsewhere, you're actually infringing on their value that they've built up by learning about it.
What it does, I guess, is that it really inhibits interoperability, right? Like if you have to pay to have your software work with some other software, then that really prevents software from working together in a way that's basically horrible. That these companies would try to extract more money from their monopoly position doesn't entirely surprise me, but I'm glad this came down the right way.
Yeah, I mean, APIs are great, right? It's something that allows you to figure out how to interact with the black box without actually knowing what's going on in the black box.
It's the data sheet of the software world.
Ooh, that's a good one too.
I won't go off on my software rant.
Everyone's waiting for it, Elliot. Let's hear it.
I can't go off on my software copyright rant because so many of our listeners are programmers, and the fact that software is a work of literature and that it is thus subject to copyright and it's not an algorithm but a creative expression is so fundamental to so many of our listeners' daily jobs that I won't go off on this rant at all.
I don't know, man. My software that I write is definitely a creative work of fiction.
Yeah. If by work you mean work, then my software doesn't even work at all.
What do we do now?
This would be a great place to start talking about the hacks of the week.
Oh, let's talk about some hacks, Elliot. So the first one that I have up is one that Carrie Sharfglass wrote called "You Otter Be Able to Stream That Audio. Open Hardware Eclipses Chromecast Audio." And this is a good one to talk about coming off of this API discussion, because this marries together a whole bunch of different wireless audio transmitting protocols into one little disc-shaped PCB that rolls in a whole bunch of features to make it better than the Chromecast audio. That, of course, is a device from Google that was very popular, 5 years ago or so, and they ended up giving it the axe. And Carrie mentions in here that the used units are going for more on eBay than they were when they were new, which is interesting. But this group of hackers, who you likely recognize their names, Nicholas Fouth, Jan Henrik, Toby Miner, and Mana Worm, are all throwing in together to make what is an incredible build. It can be ordered from PCBA, almost completely done, and then they go ahead and add an Allwinner S3 chip, which is a BGA, and reflow that along with an AP6236 Wi-Fi radio on the top. Then you can flip the board over. So you just do that on like a hot plate. You can flip the board over and add your SD card slot. There is a place for an Ethernet connector if you don't want to use wireless and you want to plug it into the wired network. And then while you're hand soldering, you also add in the 3.5 millimeter, the headphone jacks, which gives you the option of doing line in and then two different lines out. There's like a line out and like amplified headphone out for this thing.
Actually don't have a Chromecast. It's like an internet radio player device.
Yeah, so for like Chromecasts, if you're playing like YouTube and you want to listen to the audio on your stereo system, you can like click an icon while YouTube is playing, and you can select the device that's on your local area network, and it'll play through. So this can do that. There's something in here that says it doesn't actually do the Chromecast casting thing because of some snafu with implementation, but that may change in the future. But it does a bunch of others, including you've probably heard of AirPlay, which is the iPhone version of Chromecasting, and then a bunch of open standards.
I use Music Player Daemon.
Yeah, well, that'll work too. I mean, that's the thing is it's a system on a chip running Linux. So AirPlay, Spotify Connect, Snapcast, Pulse Audio, the Pulse Audio Sync. And then I was looking around, and it'll do like multi-room playing. So I think that's like a Sonos feature.
Okay, cool.
So you could like walk through your house and it'll sync up the playing of the music in different areas. I guess I've never had that problem.
Right.
But everybody's got a different use for it. Like maybe you want to have awesome parties at your hackerspace and you have sound systems in 5 different rooms and you want them all to sync up.
Yeah, that's pretty awesome. You don't have to dedicate a computer to be your home stereo system. You can just run one of these little gems on it. What you mentioned in the beginning is most impressive to me is the level of like productification, fit and finish here. Like this is... You can order it, you can get it PCBA'd, you can get most of the bad work done for you. It's put together to a product-y level, but free and open.
Yeah, and I think it was, there's a bunch of comments all over the place. I've been looking at this on Twitter as well, so I can't remember where it came from, but I think it was Jan Henrik was talking about the reflow of that ball grid array chip, which I haven't done any of that before, so that kind of scares me. And he said on that it's pretty easy. You put down flux, the chip already has the balls on it and does its thing on the hot plate.
Right on.
Yeah, I want one of these. Like, they're pretty awesome. I don't know that I'd use it. I just kind of want to play with it.
All right, my first hack this week made me think for a little bit about what it is that I like about hacks. It's really fun. Doing the podcast kind of puts me in this introspective mood sometimes. And I'm like, I really like this one. Why do I really like this one? This is a fantastic misuse of Raspberry Pi GPIO, and it's a hack by River. This is actually kind of a twofer hack. River had a ceiling fan that has a strange wireless remote protocol, and River wanted to pull it into a home automation network and make it play along, and that means spoofing these funny radio signals. And so what I really like about this hack is that this is not the like graybeard wizard in flowing crimson robes hack. This is the other kind where it's like someone who's new to a particular field, in this case wireless, and just kind of goes through all the different steps textbook and documents them along the way and, kind of just takes a leap into the unknown. I mean, in this case, River is literally buying an RTL SDR dongle for the first time in order to pull this hack off. Like, this is jumping into the field of software-defined radio into the deep end and pulling it off. So A, kudos, and B, it makes a great illustration to other people who want to do the same of how you can get started really easily. And so the first part of this hack starts off with just buying an RTL SDR dongle, looking up the frequency that the transmitter of the fan uses in the FCC's library, which is a classic trick, and then scoping around using a piece of software called Spectrum, decoding the signal that they found using Universal Radio Hacker, which is an awesome piece of radio protocol decoding software. River ends up bit banging a pin on a Raspberry Pi using RPi-TX to send out the right signals and control the fan. And of course, it's an astounding success. So you should really go check out both of these, both the like protocol decoding side and then the faking it with a Raspberry Pi side. All of the stuff is stuff you have around the house or stuff you could buy for $20. And if you've never gotten into SDR hacking, this is your ticket.
I saw some people in the comments complaining about the bit banging of the radio, and I'm wondering if they didn't actually read through and watch this, because River talks about the harmonics and how just spewing out RF is not only being a bad neighbor, but is probably illegal wherever you are. And so part of this is getting a low pass filter to make sure you're transmitting on the frequencies that you plan to for this. And correct me if I'm wrong here, as long as you have a ham license, this shouldn't be a problem, right?
I don't think you're licensed for this frequency band, and I certainly don't think you're licensed for any of the spurious emissions. But look, there's definitely nothing illegal going on here. This radio is literally coming out of the GPIO pins of a Raspberry Pi. This is not putting out watts of signal. This is putting out microwatts, maybe a milliwatt of signal. I'm sure it's not making it outside of your house and is not going to cause anyone else any problems. Second, it's such a nice thing to do to put that low pass filter. And what River does is just buys a, I guess, roughly 400 megahertz, 433 megahertz low pass filter off eBay for $7 and about the right antenna, and literally connects DuPont cables to this filter and antenna combo, and then boom, into the Raspberry Pi, and the rest is software. A, I love that. B, it makes the signal get out more efficiently. And I guess if you're worried about the spurious emissions off of this thing, it is the right thing to do. Although, my guess is that's a non-issue anyway.
But I mean, what's the difference here if I were to buy a 433 megahertz module versus doing it this way with a filter and a GPIO pin?
Yeah, so the difference here is that here it's 300 and something.
Oh, it's not quite 433. Yeah. Well, sorry I got us off on a tangent there. I mean, I do really like the sniffing part of this because it shows how powerful that software is. It's really awesome to see it recognize where each of the packets is and then spit out the binary for the packets, and then you can tell it like which edge you're looking for on your encoding, and it'll boil that down to just the actual ones and zeros of the signal you're sending. And then you can further like look at it and say, okay, the first 8 of these are the address bits, and then the last 5 of these are the command bits, and have the software like do the highlighting, and it just really makes it easy for you to work with something like this.
Back in my day when I was a kid, I had to write these routines myself in Python. I didn't have this universal radio hacker that makes it all so very easy and gooey and intuitive to explore the data like this. It's a great piece of software, and I fully recommend it. And actually, if you want to read up on this and other really cool SDR tools, you should check out a piece Tom Nardi wrote 2 years ago now, RTL SDR 7 years later. I'll throw the link in the show notes. What's really nice about this hack is that, like you said, it is 2 parts. There's this one part where it's the RTL SDR protocol decoding, and then the second part is using the Raspberry Pi and RPi TX to make up for the big weakness with the RTL SDRs, which is that they can't transmit. So with just the RTL dongle, you can listen to anything and figure out what's going on, but you can't necessarily talk back to it. And this is demonstrating how powerful it is to have this combination of an easily accessible software radio tool, even if it's kind of a dirty hack like RPi TX is, at your disposal.
Sam Battle is showing off an awesome piece of audio equipment that he built. It is the electromagnetic synth thingy, apparently inspired by something called the Crystal Palace, which I have not heard of before, but ooh, this thing is a tasty little build. It has a spinning head on it, and out on an arm on this spinning head is a cassette tape reader. And so, we've seen like, the mellophone where you'd use a bunch of different cassettes with a bunch of different heads, and you'd press a key and it would play whatever cassette was on that key. This is like kind of flipping the script on that. So you have one head, the head is rotating around, and instead of riding on magnetic tape, it is just hovering above a bunch of coils all the way around, 16 coils all the way around this circle. And then those coils are piped out to a patch board that you can then put your own custom audio inputs into. And also, I'm not sure what the trim pot on the board does. I can't remember, but you can alter.
It's just volume.
Oh, it's just volumes. You can alter the volume of each of these. And so it's kind of like a mechanical looper where the audio signals are like magnetic tape, except instead of tape, it's electrically, it's an energized coil going around, and it sounds awful and awesome all at the same time.
Yeah, this is a really cool device. I love switchers and multiplexers. And actually, when I was doing the Logic Noise series, that's my favorite element of the whole Logic Noise kit, is using a 4051 analog multiplexer to switch across from different sounds like this. If you switch rhythmically across a bunch of different things, it kind of automatically turns it into music. That's the same effect he's got going here, except what's really cool about this is because it's kind of physical, because the tape head moves over one inductor and the next, it kind of automatically crossfades. And further, he's got a really clever setup here with that patch bay thing. In addition to the volume knobs, it's also set up so that it's got two rows where one is the odd stations and one is the
Right.
even stations. And if you just put two signals in there, into 1 and 2, the one that goes into 1 replicates itself across 3, 7, 3, 5, 7, 9, etc. And the evens are the same too. So you automatically get this alternating A, B, A, B, A, B thing going on. And then if you put further ones in there, it goes A, B, A, B, C, A, B, A, B, C. And you can make these really awesome like sequences. And in the end, because you're just driving audio straight through, you can hook these things up to 16 different radios tuned to 16 different stations. Or, it's a really cool tool. The other thing I really love about it is that it's not hi-fi at all. It's like totally distorted. Like he's running audio signals through these like little inductors that are not meant to be coupling with those tape heads anyway. And so he's saturating the cores on them, and they're definitely getting overdriven, and you can hear it. It sounds really raunchy and chaotic, but then the fact that it's repeating makes it kind of rhythmic and compelling at the same time. And I think there's more to go on this because he's driving the spinny part with a stepper motor, and he hasn't gotten into controlling the speed or start-stopping that yet. But I think there's some more left on the table here. My next hack is essentially a feat of high-level electrical engineering. This is open source electric vehicle charging. It's just what it sounds like. Sebastian has made himself a 2-port electric car charging controller. And this thing is just amazing. It dots every I and crosses every T. It does everything you could possibly want it to do. And as Sebastian himself says, this project was a real full-stack project, reaching from hardware electronics all the way to front-end web app. I mean, basically the problem isn't very hard. You just need to control two extremely high current, high power energy streams and control them remotely over the internet using an Arduino Nano and a web interface.
What could possibly go wrong?
22 kilowatts. This is two like 20 amp 400 volt circuits going into these cars to charge. Why would you want to do this? Well, you might want to monitor how your cars are charging. You might want to charge them when the power is cheap. You might also want to match charging your cars to a solar panel if you've got one in your house. It just opens up all these crazy possibilities.
Yeah, well, I think he mentions that charging when, at off-peak rates, and I think that's a really smart one. And if you're already, piped through to the web, it should be pretty easy to pull, some rates API from somewhere in order to do that planning. The only thing about that is, like with my laptop, it's always when I need it unexpectedly that it's not charged, right?
Exactly.
It does raise an interesting question, though. As we move more towards a world of electric vehicles and not internal combustion vehicles, Do you start to see like major grid spikes like at the arrival time at the office each morning as people get into parking spots that have chargers, and then the arrival time back home?
Yeah, you absolutely will.
There's going to be charging valets.
For you.
Yeah, there'll be some, like it'd be like a night guard, right? The night watchman will come in, and the cars that need to be charged overnight, that person will pull them in and out of the bays and make sure they all get charged.
But back to this project, which is
all right.
this is the valet that you wish you had, right? Because this is, oh, I forgot to turn my car on the charger. You flip open your cell phone app that he has written for this, by the way, and you press charge, and you can watch it charging in real time. This one, again, its full stack is often so much BS. In this case, he's really serious. He's written the firmware for the device, but then also the logging firmware, and then the server that implements that, and then a little phone app to, I guess it's a web app, but it can run on your phone using WebSockets to do everything in real time. Really sweet. I think the things that I really liked about this were all of the kind of well thought out details, like the firmware for the chargers is OTA upgradable, because you don't always want to go down to your basement and stick some, programming connectors into this thing. The other thing that was shocking about this to me is how expensive this project is. And he has the entire bill of materials broken down here. And I guess the PCB itself is probably a little bit expensive, but that's not where the bodies are buried. It's all of the things that turn this into the kind of professional project that you should probably have for something that's pushing 22 kilowatts, including like a ground fault breaker and professional grade contactors to switch the cars on and off. And, even just the right sockets to plug your electric car cable into cost $80. And so there's a lot of money here, but that's just the cost of doing business and doing it right. And I think what he ends up with, though, is this, entirely personalized, do-it-yourself, hackable. This is taking the control of charging your cars and taking it back for yourself. And I think when you combine that kind of freedom with the safety that this thing has, it's actually pretty cheap.
Well, don't worry, we will not get off track on this next one. It is a straightforward and simple hack that is so, I guess, minimal, it seems almost magical. This is Hobie Serdos's Pterothopter. It's an ornithopter made to look like a pterodactyl. And so, of course, ornithopters are flapping flyers. So they don't have a propeller on them. They flap their wings kind of like a bird would in order to move through the air. This is, of course, rubber band powered. So you wind it up and it has kind of an offset cam that flaps the two wings and provides lift. This is a nice little look through what I would say would be a very typical experience. You build the thing, you start it flying, and immediately flies into the ground, and you spend the rest of your time trying to troubleshoot it. The great thing about it is it totally works in the end, and I was surprised to see it flying outdoors. You would think that any kind of air movement would just wreak havoc on this, but it does pretty well for itself.
Yeah, you say we're not going to get off topic. How can you not get off topic when you have... This thing is huge. I don't know if you looked at it for scale somehow. Like, it's a 60 centimeter wingspan. So that's 2 feet to you American units, peoples. That is pretty darn big. And it's all made out of like balsa and some kind of cling film or something for the wings. It is so awesome looking.
Yeah, the original comes from a plan that was in a newsletter, the Flapping Wings newsletter, summer of 2017. And the last couple pages of this are the hand-drawn plans for this, and they do lay it out as a 23-inch wingspan. Now, this original design used tissue paper for the wings, and then the one that we're looking at today actually has some translucent plastic film on it. I was looking at that wondering how they applied it, if it's just glued on, or if there's some other method for that. Any ideas?
I'm sure it's just super glue, but what do I know?
Balsam wood and super glue. Could it be easier?
The thing is flying. It's got to be made out of balsa wood and super glue, right?
I love ornithopters.
I do too. Bringing up the rear this week, this custom dynamometer is a sterling example of home brewing. This is the second video in a two-part series by Leo Fernekes. He's making a Stirling engine, but his engineering side has kind of gotten the best of him. Normal people make Stirling engines, which are heat engines, just to watch them spin, and they're happy with that. But Leo is like, how well is it spinning? How much power is this thing putting out? I could make a better one if only I could quantify how much power it was making. That's what this video, the second in the series, is actually about, is building this custom dynamometer. And that is a fantastic look into kind of scratch building a reasonably sophisticated piece of test equipment, but then also just Leo's approach to building a sophisticated piece of test equipment is so refreshing. He's like, I don't know if this is going to work. I'm going to test this part. And then I'll do this and I'll test this part. And he kind of bootstraps himself up from all of these minimally sufficient dynamometers up to something that's actually really sweet in the end. And somewhere near the end of the video, he comes up with a quote about why you want to be doing these like sketchy little tests, he calls them. He says, even if at the end of your sketchy test you have to do it again, it helps you design the right experiment the next time around. And I think that's exactly right.
I was really delighted by his discussion of building his own positional sensor here, because I think it was just last week that we were talking about those servo motors that had an optical encoder inside of them that used like an off-center wheel, and so it was kind of like an analog thing. This is a very similar take on it. So he's taking an optical sensor and he wants to, instead of having like an on-off cut like you normally would, wants to be able to tell like how far the blocker has moved in between the transmitter and the receiver. And so like goes way down the rabbit hole, actually sourcing a crappy light sensor. And in this case, it's just an LED. And because that doesn't have a good cutoff, it's not engineered for that. And then talks about problems with like temperature drift on that. And so ends up having a second sensor that is just the transmitter and receiver connected directly to each other, so that you can look at like how well that is performing with nothing blocking it, and then you can tailor your results from the actual sensor with that. It's brilliant, and that's just a tiny bit of this build.
To put this in perspective, he has to start off with this motor that may or may not be very efficient, and so he has to couple with it in a way that doesn't disturb it, because it's a little bit of a sensitive thing, the Stirling engine. And so what he does is he puts an aluminum flywheel on the Stirling engine. The wheel in his dyno has electromagnets in it, which couple to the eddy currents induced in the aluminum wheel when that thing spins. And so it's like an eddy current brake, basically, except it's an eddy current brake where you can adjust how much braking it puts off by adjusting the current going through these electromagnets. And that is connected to this position sensor that Mike was talking about, that holds its position basically by servoing it by increasing or decreasing the amount of torque it puts on the Stirling engine through this eddy current brake, then uses the measurement of how much power that takes to figure out how much power the engine is putting out.
I think you got to go and watch the video to get the gist.
Absolutely.
Yeah.
You should absolutely go and watch the video. And if that doesn't do it for you with dynamometers, we have linked in this one another great article about dynos where Jeremy Fielding built a significantly higher power dynamometer. This one is kind of the low power, ultra sensitive version of that. And it's just full of little awesome details.
It's cool to see Leo pull his toolkit out on this one, because, you know, this uses that eddy current brake, and we saw him make that clock. Do you remember that clock that was like a vertical tracker, and it used like a saw blade to lift the thing up, and then it would eventually disengage and let it fall back down? He used an eddy current brake with a slug of aluminum for that as well.
And it's a super cool party trick.
First up on my list of quick hacks is a science fair project by Daisy Taylor. She looked at making sutures that can sense when there is an infection on the wound site. And they do this by using a substance from beet juice, which turns colors when it gets to a certain pH level. And it just happens that healthy skin will be below that pH level. And just before an infection is about to get out of control, the skin will spike above that pH level and make the color change. That's very awesome. Make sure you click through and watch her presentation. She does talk about this being really useful in places where access to emergency medical assistance is difficult, like in the developing world. So having something where a patient or a caretaker could very easily know if there's a problem and then start making plans for getting help would be a really awesome advancement. Next up, you can now build your own glowing LED D20. This is Greg Daville's project, and I watched it lovingly last year when he was putting so many LEDs on these tiny triangles and then putting them together into not a cube, but a D20, a 20-sided die. And in this case, all of the files to make your own have been published on GitHub. You're going to have skills like Greg Daville, but I think there's a lot to be learned from here in what he does, even if you don't build this exact project. And finally, playing Snake on a PCB. Jenny List picked up on this story from VK5HSE, who decided to code the game of Snake into PCB layout software. So the Snake is actually a circuit board trace that you're driving around all of the other traces in your design. This is built as a plugin or an add-on for PCB RND, but is a great way to show off the power that these add-ons for different EDA softwares have and start you thinking about all the crazy shenanigans you can do with them.
My first quick hack this week is ML Smith's music production studio in a box. We've seen a lot of cyberdecks, which are kind of post-apocalyptic styled computers that you can lug around with you. This is the music studio to go along with a cyberdeck. It's got an Octatrack, an Access virus, it's got an Intel NUC, and it's got a small touchscreen. All of that jammed together with enough battery in a beautiful case with rubber seals and like those gas struts to hold it open. This is a fantastic portable music production studio. It sounds good, looks good, and it seems to work well. Next up, solid tips for casting colored silicone tires. If you're making any kind of robot, you might want more grip. This is how you're going to get it. Concrete Dog D0G works through a bunch of awesome tips for making 3D printed molds and then out of department store silicone caulk and some acrylic paint, making your own custom silicone tires for small robots. The extra juicy tip here is that you can use glow-in-the-dark paint to get yourself some glow-in-the-dark treads. And last up, Arduino plots your portrait with style. This is a drawbot, or I guess I should say paint bot that Ben built. It's got a video camera, it's got a screen. You press the button when you like the picture it's got of you, and then it draws it out using a 2-axis robot. What's particularly cool about this is that it does it all not with a Raspberry Pi, not with a 555 timer either, but with an ATmega 256 based Arduino Mega. And that's really cool because it doesn't use more processing power than it needs. It also doesn't have more mechanical stability than it needs. The thing has all sorts of crazy slop, but because it paints from one side to the other, the backlash in the system is worked out by the mechanism, and it ends up making beautiful, if slightly quirky looking, computer-drawn photos.
It's time for our can't miss articles of the week. This is long form content written by awesome Hackaday writers, and this week I chose one by Stephen Dufresne, Death of the Turing Test in an Age of Successful AIs. Stephen goes through and talks about a new program that IBM has out called Project Debater, where they're taking their Watson API and putting it to the test on stage in the world of debate. So this is organized arguing where you throw down a topic and you assign a side to each of the people, and there's very drawn out parameters for what's going to happen. So you're going to have a certain number of minutes for your opening, and then the other person will do the opening, and then there's argument back and forth, and you can actually go and watch this. I think an interesting part of this article is that Stephen talks about the Turing test, which was originally something that people think of as establishing whether or not computers can think. And then looking at it in this context and with some of the AI developments that have happened recently, what I didn't realize is that the Turing test is not quite what pop culture has it drawn out to be. So the question of, can computers think, Alan Turing thought is a difficult one to answer. And so he actually reimagined what this test would be. And it was a test called the imitation game. It's just, since this paper has come out, that it's been more widely known as the Turing test. But with the imitation game, you actually take an interrogator who is questioning a man and a woman, and one of the two is tasked with helping you figure out which is which, and the other is tasked with trying to hinder that, so trying to fool you. And then in playing this game, you need to try and figure out which person or which one of the two entities that you're interacting with is not the human.
It doesn't answer the question, which is, can computers think? But to answer that question, you have to figure out what thinking is, and that's hard enough already.
The sardonic rebuttal is, can I think, right?
So this kind of boils it down to something you can easily observe, which is a conversation being had, right? And so, yeah, it's kind of a good proxy for that. But what it really is a really good test of whether the machine can seem like it's producing human speech, seem like a human writing.
Yeah, so I think in the case of this project debater, you can go and watch it, and you're going to get some laughs from it. So like 12 minutes and 48 seconds into it, the computer's doing so well. And the text-to-speech, it sounds pretty good. But then it says more successful lives, and it means more successful lives. And that's one of those things where like immediately you're going to jump on that. And then there's like the monotone of it. It's kind of hard to follow along. I also think it's comical that, in this live presentation, they forgot to mic the robot.
Yeah, right.
So for like the first minute or two of the opening statement, you have to like turn your volume way up and it's still poor audio. But then they fix it after that. But if you discount that to something that's in writing, I think absolutely you would be able to think that both of the people in this debate were human.
I don't know. These days, it's really hard to tell what the Turing test is. And because we have more familiarity with AI, it naturally makes it easier for us to tell AIs from people. And so this no doubt would have passed the Turing test with flying colors in 1980. But in state-of-the-art 2020, I don't know. I mean, it depends on how sophisticated the audience is. So I listened to this thing, and first of all, the debate topic is whether the state should fund kindergartens. That's kind of a really easy one to argue the pro side for, and a really difficult one to argue the negative side for. And the human got the negative side on that one, that we shouldn't spend more money on kindergartens. So the computer was able to draw on all of this previous research by all of like child development psychologists and stuff. And this is the sort of thing that Watson's AI system is really good at, which is kind of digesting and repeating results from previous studies. And if you actually listen to what it's doing, it's just doing that. It's just saying, here's a related study where they found this. That's really impressive. Do not get me wrong. I think that's super awesome. And like I say, it would have fooled someone back in 1980, absolutely, certainly. But today, it doesn't provide evidence of kind of inventiveness. It's just citing sources.
I think the thing that you have to look at is that it doesn't just pull that research, but it has to validate on whether it, goes towards making their point. And that's hard to do.
This is definitely a very well-trained AI. I'm not saying it isn't. That's, This is IBM's flagship here. This thing, there's been a couple dollars spent on training this thing up. And in that sense, it's really remarkable. But, if you go back to the Turing test question, is this providing evidence that the machine is thinking? It absolutely isn't. Is this passing as a human? I think back then it would have, but nowadays we've raised the bar to include humans are creative and not just humans can go do their research. All this kind of brings us to Stephen's last point, which I think is really good. Does the Turing test matter anymore? And his point is that we've got a lot of functional AIs out there doing functionally useful things like driving cars or understanding people or going out and fetching the relevant research material. And these are incredible things for computers to be doing, and they're doing that sort of thing well. Does it even matter that we would be fooled into thinking they're people, or if they're thinking at all? And I think the answer to that is no. I think the bigger answer to this in kind of the Turing test context is that the Turing test isn't really the point of AI anymore.
Yeah, and I thought that as well. I mean, I think we continue to move the goalpost, right? And so what we consider to be thought and what would have been considered to be thought when the paper was first written are very different. But I mean, do we have a test that people are, I mean, what are we even testing for, right? I mean, I think the pervasive AI is going to be doing mundane things for a while.
Yeah, the test is stupid. The test is not a test we care about.
Right. Yeah. And so like, we're not looking for thought. We're looking for like time and labor saving results.
I just want to order a pizza and I just want the AI to understand that I want pepperoni on it. I don't care about any of the rest of it. It doesn't have to be smart. It doesn't have to be creative. It just has to get my order right. All right, my can't miss article this week is Adam Zalouf's Python will soon support switch statements. And that title is a little bit misleading. What Python's putting in here can be used as like a switch case statement that you see in languages like C, and that according to people who aren't super familiar with Python, Python is lacking. What match statements really are is more flexible. You can use them to match like a number against another number and then make a decision based on that. But you can also use them, it's like a switch case statement that matches the type of the things it's got. So a really great example of this pattern matching power is that you can write a match case statement that will notice if it's been passed 2 arguments or 3 arguments and match differently depending on that. The great example that Adam has here in his article is the case of dealing with 3D points. Maybe if the function only gets given 2 coordinates, you want to pad that out to a 3-dimensional coordinate by adding a 0 to it. So you can have a case that matches when you only get 2. You can have a case that matches when you get all 3 coordinates and it puts that into a 3-dimensional coordinate. That sort of thing is significantly more flexible than just a switch case, which Python can handle entirely well by using dictionaries of functions. This is something else. This is something that kind of brings a little bit of the C++ polymorphism flavor into Python. And whether that's a good thing or not, we can argue about all day long. But it's more than just a switch statement. And this is a change that is live in beta versions of Python 3.10 and will be probably coming soon to a language near you.
Yeah, I think it's pretty cool to look at the ability to boil down what would be, like you said, polymorphic functions, where you would, define one function name, but you would execute it differently depending on what data you had coming into it. Now you can just have the data come into it and use a match statement within it, and then you can match the format of it. So is it a tuple of 2 different values? Is it a set of 3 values? Is it already an object of the type that you're looking for, and in which case you can just return that? So that's one of the examples that he put here. I've definitely used dictionaries of functions before, like you mentioned, and those are fine. I mean, you can even pass parameters using that. It's just like calling a function, except before the parentheses, you put square brackets with the key to the function in the dictionary that you're looking for. But I always found that to be like a little bit wonky if you didn't already have an existing function for each of the things you want to do with that switch statement.
Yeah, I know what you mean. I actually really like that kind of formalism that makes you go through. Like that makes you think, what am I going to do when this happens? What am I going to do when this happens? What am I going to do when this happens? And you kind of like write handlers for every possible case there. And then you just put those handlers in a dictionary and you're off to the races. I really like that style actually. And I do something similar in C when I'm doing state machines all the time. I'll do, an array of function pointers that then point off to state handlers, right? I really like that kind of thing that the old Python dictionary used to have. And I'm actually afraid that because you can use it as a switch case, I'm afraid that people will do that in Python. And
Yeah.
I'm kind of bummed because that's, it loses a little bit of that extra special Python dictionaries are a really important object type flavor, but also because that's where the super horrible bugs will be buried. And I have to point to a really funny piece by Stephen Brennan. I'll put the link in the show notes here. The headline is Stack Overflow users rejoice as pattern matching is added to Python 3.10. The idea is that Python's such an easy language to write in, nobody's getting any points for correcting people's code on Stack Overflow, and that this is going to be their savior because it's got some horrible problems. Like if the thing you want to match against is in a variable and the thing you're matching is a variable, they'll match. So you can use this match case to match against the number 3, but if you then use it to match against a variable called myNumber that has 3 in it, it's going to match the variable that you put in the match part of the match case because variables match variables. They're of the same type. And this is going to cause people some bugs that they're not going to figure out for the first couple years. And
the fix to that is
yikes.
to encapsulate that variable in an object, because if it's object dot my number, then it'll translate to a numerical literal instead of to the type variable.
And this breaks one of the things I
like. That's even more
like.
confusing.
And this breaks one of the things I like most about Python, which is it lets you do object-oriented stuff, but it doesn't usually force you to. And in this case, it's forcing you to make a class so that the class can have this member that has the value that you want to compare against. Gah!
On the other hand,
Gah!
I have some Python projects that got so big that you have to do classes.
Oh, sure.
Because it's too much to keep track of. And so maybe it's just, you were just advocating for having a function for each different thing that you want to do in your switch statement. And I didn't want to do that because I'm thinking about smaller, lazy programs. But of course, when they grow bigger, you have a million functions. And then you start to have classes that have the functions in them so that you can organize your functions more. So, maybe it just depends on the scope of your program on using this. When you get right down to it, though, I've used huge elif chains in Python before, and that works. It's just like my OCD of looking at all those elifs. I'm like, that should be a switch statement.
There should be an
that's
easier
the
way.
non-Pythonic C programmer saying that, right?
So I think using this match case as a switch case is going to be looked upon later as bad style because it opens up a bunch of bugs and it underuses the thing's real power, which is to do these kind of bigger syntactic matches. My guess is that in a couple years, this will all shake down and only the really bad, lazy Python programmers will be abusing this as a switch case. That's my hope anyway. But until then, we got some bugs to look at. The other thing, and this was brought up in the comments by retired Jan, is that this matching by syntax is really hard for the Python interpreter to do. And this is going to be a real pain in the butt for the MicroPython people to import
Right.
into small resource constrained embedded devices. And yeah, I wouldn't be entirely surprised if this particular function doesn't make it into MicroPython anytime soon.
Oh, don't worry. I'm sure this function will be deprecated in the tectonic shift to Python 4.
When's Python 4 coming out?
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. I just switched to Python 3. Not go there.
oh no,
Oh yeah,
you didn't warn me of this.
cut all that out. You're welcome.
You won't believe what happens next. Do you hear a fire truck?
Finally, after 10 years.
Got it. That's a wrap.
Which is really just a burrito. Sounds really good.